Good morning, all. Today we are going to start the probability. Last few sessions we were discuss about the R, basics of R, how do we handle the data in R. Now today we are going to discuss about the probability. Probability is one of the most important topic for the data science as well as the modeling part, whatever you think. So everything, whenever we are telling to the client, whenever we're talking about the information, mostly we will talk in terms of the probability value. We are going to discuss about the basic probability. Once we done the basic probability, we are going to discuss about the probability distributions. Okay. Here in the probability, what do you mean by probability? Probability, what do you mean by that? What is the definition of the probability? It is a chance of or getting or occurrences. It is a chances. It is a chance of or getting an occurrence of an event. Probability is nothing but it is a chance or getting an occurrence of an event. Now you may get the doubt. What do you mean by event? Event is nothing but any resultant outcome, any resultant outcome or a procedure of a procedure. Any resultant outcome or a procedure is called as events. Any resultant outcome or a procedure is called as the events. Events has been classified into two different types. First point, first we are discussing about the probability. Probability, the definition of the probability, it is a chance or getting occurrence of an event. What do you mean by event? Any resultant outcome or a procedure is called as the events. Again, events has been classified into two different types. First one is simple event, second one is rare events. Events has been classified into two different types. Events has been classified in two types. One is a simple events, other one is rare events. What do you mean by simple events and what do you mean by rare events? Simple event means any resultant outcome that cannot be broken down further. Those are called as the simple event. Any resultant outcome that cannot be broken down further. For example, if you toss a coin, what are the possibilities you are going to get? Head or tail? Is it possible to divide head and tail? No, right? Those are called as the head and tail. The outcomes we got head as well as the outcome. We may get the head or we may get the tail. Either of the one. Is it possible to break down further head as well as the tail? No, it is not possible to break down further head or tail. Those events are called as the simple events. Any resultant outcome or a procedure that cannot be possible to break down further. As an example, if you throw a die, what are the possibilities you may get? You may get the 1, 2, 3, 4, 5, 6. In all 6 cases, either one of the possibilities might be possible. Either one can be answer, two can be an answer, three can be an answer, or four can be an answer, or five can be an answer, or six can be an answer. But is it possible to break down these outcomes? No, it cannot be possible to break down these outcomes. So these outcomes are called as the simple events. Clear? Okay, what do you mean by rare events? Rare event means the probability of these events are very, very small or very, very minute. The probability of these events are very small or minute. For example, winning a lottery for the first time will be a fair. Winning a lottery for the first time is a fair. Assume that winning a lottery consecutively in a row of 20 times. Is it possible? No. Even if it is possible, the probability of those events are very, very, very less. Even if it is possible, the probability of those events are very, very, very less. Right? Those events are called as the rare events. Rare event is one of the important point we are going to consider in further our discussion. But whenever we receive the rare events, we are not going to consider those probabilities. We are not going to take in consideration of those probability values. So here, where do we use? Let's say, let me give you one small example. Let's say, in a classroom, assume that in a college, 10,000 members were there. Assume that 11th or 12th standard. One person behavior is altogether entirely different with the remaining 9,999 people. Thus, one person is called as a rare person or an outlier. Simply, we can say, or we can also say that rare events are also called as an outliers or extreme points. Simply, we can say rare event is also called as an extreme point as well as an outlier. So we never ever consider the rare event points or exceptional points in our analysis. Clear? Rare event points, rare event points, we are not going to consider into our analysis. Okay, clear? Now the next point will be here, how do we denote the probability value? Probability is denoted with capital P. A, B, C, and so on, X, Y, Z, or these are called as the events. A, B, C, and so on, X, Y, Z, anything it can be. Capital A, capital B, small b, anything it can be called as the events. Anything called as an events. For example, P of A means probability of A. How do we define that? Probability of A, that is correct. How do we define that? If I want to tell as a layman terms, no, here P of A means probability of getting a chance or occurring of event A. That is the meaning of P of A. So sometimes may ask in interview, they might ask you, can you tell me in layman term At that time, you have to tell like this: P of A means probability of getting or occurring event A. P of A is nothing but probability of getting or occurring event A. For example, probability of X means probability of getting or occurring event X. Okay. The range of probability values are in between 0 to 1. The range of probability values are in between 0 to 1. 0 means impossible to occur. 0 means impossible to occur. 1 means certain to happen. Zero point 0.05 means unusual to occur. Zero point 0.25 is unlikely to occur. Zero point 0.5 is 50-50 chances. 50% chances. 0.75 is likely to happen. Zero means impossible to occur. 0.05 is unusual to occur. 0.25 is unlikely to occur. 0.5 is 50-50 chances. 0.75 is likely to happen. 1 is certain to happen. 1 is certain to happen. Okay. Everyone understand? Okay. Now, probability has been classified into 3 different types. Probability has been classified into 3 different types. One is relative frequency approximation, relative frequency approximation, or approach. You can say approximation or approach. Second one is a classic approach. Third one is subjective approach. Probability has been classified into 3 types: relative frequency approximation, classic approach, as well as subjective approach. Classic approximation or approach, both are the same only. Probability has been classified 3 types: relative, classic approach, or subjective approach. Here in this case, let me any questions, guys? Okay. Let me have a discussion about relative frequency, classic approach, and then subjective approach. First one, let me have a discussion about relative frequency approach. Relative frequency approach. What do you mean by relative frequency approach? Here, how many times particular event is occurring divided by total number of events are happening. The relative frequency approach means how many number of times particular event has occurred divided by total number of events are occurring. How many number of times particular event has occurred divided by total number of events are occurring is called as the relative frequency. If you remember, we have discussed about the relative frequency. When we're discussing about the frequency table, we are discussing about the relative frequency. There, what do you mean by relative frequency? Particular frequency of a particular class divided by total frequency. That is called as the relative frequency. Here also, let's say, if I toss a coin for 100 times, if I toss a coin for 100 times, what is the probability to getting 30 heads? If I toss a coin for 100 times, what is the probability getting 30 heads? As per the relative frequency, how many number of times particular event has occurred divided by total number of events. How many number of times particular event means what is occurring here particular time? Heads. How many times it is occurring? 30 times, right? Head is occurring 30 times divided by total number of events, or what is the total number of events? Total number of events are the 100. So what is the answer? 30 divided by 100, that is nothing but 0.3. For example, okay, that is cool. Let's say I toss a coin for 100 times. Please be careful. I toss a coin for 100 times. What is the probability to getting 110 heads? Let me repeat my question. Let's say if I toss a coin for 100 times, what is the probability to getting 110 heads? Is it possible? Not possible at all. If I toss a coin for 100 times, maximum of maximum you are going to get the 100. You are not going to get the 110. So that is the maximum possibility of 100. So the probability value will never be ever more than 1. Okay, clear? Here the formula is, this is the formula, simple formula. How do we write? Number of events, particular events occurred divided by total number of events. Let me write down the formula, simple way formula. Okay, let it write first. Okay, ready? Okay, here the formula is, relative frequency formula is number of particular events by number of particular events divided by total number of particular events divided by total number of events. That is the meaning of the relative frequency. Here relative frequency, what we are given example, if we toss a coin, we are going to get either head or tail. Is it an equal probability we are going to get either of the one? No, right? Either one can be an answer, but tail cannot be and head cannot be. But as we said, so when I toss a coin, head may happen or tail may happen. To getting head is a 50% chance, to getting the tail also 50% chance, equal proportion. But what if the case when I took the die, when I throw a die. So in this case, how many possibilities we have? 6. Either 1 can be happen, 2 can be happen, 3 can be happen, 4 can be happen, 5 can be happen, or 6. Are we going to get equal proportion for each and everything? In this case, no, we don't have an equal proportion. Let's say first one can happen, second case 2 may happen. So the drawback of relative frequency, it doesn't give the equal proportion to each and every event. The drawbacks are it doesn't give equal proportion to the each and every it doesn't give equal proportion to the each and every events. Okay, here in this case, to counter this part, we are going to give the equal proportion to the each and everything, that we are going to discuss in classic approach. Is it clear, guys? Is it clear who are on the call? Any questions?
No.
Could you explain that again?
Which one? Hello?
Yeah, can you explain the drawback once again?
Yeah, sure. Here, in the drawback of a relative frequency approximation, it doesn't give the equal proportion to the each and every event. For example, if you throw a die, there are the 6 possible outcomes. Those are 1, 2, 3, 4, 5, 6. Either 1 can be answer, 2 can, 3 can, 4 can, and 5 can, or 6 can. It doesn't, there is no equal proportion to get the 1, there is no equal proportion to get the 2 as an outcome, there is no equal proportion to get a 3 as an outcome, there is no equal proportion to get the 4 as an outcome, there is no equal proportion 5 as getting an outcome, or 6 as. To overcome this is a drawback of relative frequency. To overcome this problem, we are going to use the classic approach. Why we said it is a drawback? The reason is, here in this case, only particular event how many times occurring divided by total number of times. We are not thinking in the perspective of equal proportion. Only just as per the definition of the relative frequency, what we are thinking, number of particular events. Number of times particular events is occurred divided by total number of events. Just we are focusing only particular event. We are not looking about the each and every other events also. So that is the reason we can say it is a drawback of relative frequency. To overcome the drawbacks, we are going to use the classic approach. Classic approach means, what do you mean by classic approach? Classic approach means it is giving an equal chance or equal proportion to each and every other events. It is giving equal proportion to each and every other event. It is giving equal proportion to each and every other events. For example, you are attending a bank exam which consists of 100 marks. Bank exam consists of 100 questions. Each question 1 mark is the 1 mark. Okay, forget about the marks. How many questions we have? 100 questions. We are attending a bank exam. So in the bank exam, 100 question. Each question is having 4 multiple choice answer. Each question is having 4 multiple questions. One is, for example, A can be answer, B can be answer, C can be, or D can be an answer. You are attending a bank exam. In bank exam, there are 100 questions. There are 100 multiple choice questions. Each question consists of 4 possible answers: A, B, C, or D. Okay, A, B, C, or D. What is the probability to get the correct answer? Out of 4, how many correct answers will be there? 1 can be a correct answer. Out of 4, how many are the wrong answer? 3 will be the wrong answer. What is the probability to getting the correct answer? 1 by 4. Again for the relative frequency, 1 by 4. What is the probability to get the wrong answer? 3 by 4. That is the simplification of classification problem. Let me tell you an example again. Banking exam. In banking exam, there are 100 multiple choice questions. Each question consists of 4 answers. A can be answer, B can be answer, C can be answer, or D can be answer. What is the probability to getting 1 correct answer? So 1 correct answer is 1 divided by how many chances are there? 4. So 1 by 4. So can we say 1? You cannot say the 1. The reason 1 by 4 you need to set how many times particular event correct answer occurring divided by total number of events. How many times it is occurring? 1 time divided by total number is 4. That is the meaning of 1 by 4. What is the probability to get the wrong answer? What is the probability to getting the wrong answer? Wrong answer is 3 by 4. What is the probability to getting the wrong answer is 3 by 4. Correct answer is 1 by 4. Wrong answer is 3 by 4. Okay. This is about the classic approach. Okay. Now, what is the third one? Subjective approach. Any questions about the classic approach? No.
Hi, Kruti.
Yeah. Yes.
Could you please take an example of die in this classic approach?
Die doesn't work here also, because the reason here we are giving the equal proportions, right? Die.
Yes.
Here we are, what is the main object of classic approach? We are giving the equal chance to occur. Suppose if you take the die, 1, 2, 3, 4, 5, 6. When I throw a die, let's say in this case, if you take 1, 2, 3, 4, 5, 6 chances are there. If I throw a die, 1 can be an answer, 2 can be a correct answer, 3, 4, 5. But here we are not classifying the thing. As we discussed, classification, classic approach means classifying. We are not able to classify. What is the probability not getting the 2? 5 by 6. What is the probability not getting 2? That is 5 by 6. But we are not able to classifying versus like correct or wrong places, because each and every option here, each and every event are independent with the other events. One is independent with the 2, 2 is independent with the 3, or vice versa. 3 independent with the 4, or 4 is independent with the 5, or 5 is independent with the, each and every answer is independent with the other. So we are not able to classify the thing. As we discussed the classic approach, we are classification. We are classifying it true or false, like correct or wrong answer. Like we are trying to classify, but here we are not able to classify the things because one is independent with the other. So in this case, we cannot apply the classic approach. Confusion? Yeah. Here, the reason why first point we were discussing the two probabilities. One is the relative frequency, second one is the classic frequency. Relative frequency, what we are doing, how many number of times particular event has occurred divided by total number of events. For example, let's take an example. How many times particular event only we are discussing? The event can be dependent or independent, right? What do you mean by dependent? What do you mean by independent? Let me have a discussion first about what do you mean by dependent, what do you mean by independent. Independent means one is not influencing the other. Let's say you and your father, let's say you are doing or earning the money. For the money purpose, are you depending on your father? No, right? You are earning, you are doing a job, so you are getting good hands of money into your pocket every month. Are you going to still depending on your father? No. That means you are independent with your father in terms of the money, right? So your father is not influencing you in terms of money. I give the money only 5,000, so you have to survive for the entire month. Is he going to save you for this world? No, right? Because you are earning the money, you are know how to spend the money, you are purely independent in terms of money with respect to your father. So one event is not influencing the other event. Assume that you are the one event, your father is another event, your father is not influencing you. So one event is independent with the other event. Those are called as the independent events. One event is not influencing the other events. So these are called as the independent events. So let me give one small example. Let's say if you toss a coin, what is the possible to happen? Head or tail. For example, first toss a coin first time, I got a head. Is there any guarantee second time am I going to get the head? Is there any guarantee second time I am going to get the tail? First trial is influencing the second trial? No. Can we say first trial is independent with the second trial? Yes. That is the meaning of the independent here. Dependent means one can influence the others. Dependent, one event can influence the other events are called as one event can influence the other. Let's say you are working in an organization. Let's say your manager said that don't do this work. Are you going to do that work? Let's say your manager said that you have to complete the your task by today. What will you do? As your responsibility, you have to complete your task by end of the day. What if you did not complete your task? There might be some session is going to happen for you, and that means is your manager in a position to influence you either positive way or in a negative way? Is in a position to influence you? Yes, definitely is going to influence. So the relation between the employee or manager, or relation between the employee and company is in a dependent or independent? Dependent. Always the company said that there is no need to come tomorrow onwards to the office. That means your job is gone, right? So you're always in a company, your company is in a position to influence you. That means you are dependent on your company, right? So that is the meaning of the dependent here. So as we discussed the classic approach, one event is depending on other event. For example, we took the 4 options A, B, C, D. So out of that, we are trying to classify the things. How many classifying? Yes or no kind of things we are classifying. True or false, correct or wrong. So if it is the 3 or the wrong, that means all 3 are the independent. The correct means that is the dependent, right? That is the meaning of the class. So independent events, for the independent events, we cannot use the classic approach. For independent events, we cannot use the classic approach. Is it clear, guys? Any questions? Okay. Next, final approach is the subjective approach. Subjective approach, there is no formula, there is no standard rules for the subjective approach. It is purely depends on the particular person knowledge or whatever the information particular person has gained. There is no standard definition or there is no standard formula. Just it is purely depends on a particular person, how he perceived the things, how he gained the information. It may depend from one person to one other person, or it may purely independent from one person to other person. Let's say last year I experienced good heat in the summer in Bangalore. There would be, as per my experience, last experience, this year also we may experience same thing in this summer. That is my experience. You may felt that last year it is a very cold. There would be a more probable chances this year also it may go cold in the winter. That is again 1% perception about the situation. That is the meaning of subjective approach. There is no standard formula for this. So let me summarize the 3 things. Relative frequency is nothing but how many times particular event has occurred divided by total number of events. That is the meaning of relative frequency. Classic approach means we are giving equal proportion to each and every other event. For competitive exams classification problem, we are going to use the classic approach. Third one is subjective approach. Subjective approach is a purely depends on a particular person, how he perceived the things, how he or she gained the information. There is no standard way to measure the subject approach. There is a subjective approach. There is no standard way to measure the subjective approach. It is purely depends how people are perceive the things. It is purely depends how people are perceive the things or gain the information or gain the there is no standard way to measure the subject approach. It is purely depends how people are perceive the things or gain the information. Okay. Now, next one is complementary events. Next topic is complementary events. Complementary for example, P of A is nothing but what is the P of A? Probability of getting or occurring, probability of getting event A. P of A bar means probability of not occurring event A. P of A bar is nothing but probability of not occurring event A. P of A bar is nothing but probability of not occurring event A. Here in this case, let's say as an example, we said that there is a 70 as an example, there is a 70% probability today rain is going to happen in Bangalore. What is the probability not happening the rain? 30%. So total probability should be equal to 1. Probability of occurring plus probability of not occurring should be equal to 100%. That is nothing but 1. As an example, probability to happen rain today, probability to happen rain 70% of rain today is 70%. What is the probability not happening the rain? What is the probability to not happening the rain is 30%. What is the probability not happening the rain is 30%. What is the probability to not happening the rain is 30%. Okay. Now, for example, let me give one example. GE General Motors, General Electrical basically, wants to recruit the 50 members. Example, GE wants to recruit 50 drivers to their new cars. Out of 50, they selected 20 are men. Out of 50, they are selected 20 are men. What is the probability not selecting the men drivers? What is the probability not selecting men drivers. GE wants to recruit the 50 members to their new cars. So here, out of 50 they are selected, 20 are the men. What is the probability not selecting the men driver? 3 by 5. So that is the probability of men is 20 by 50. Probability of women is equal to 1 minus probability of men, that is equal to 1 by 20 by 50, that is equal to 30 by 50, that is nothing but 3 by 5. GE wants to recruit the 50 members to their new launched cars. Out of 50 they were selecting 20 as a men. What is the probability not selecting the men drivers? The probability of men is 20 by 50. Probability of women is equal to 1 minus probability of men, 1 minus 20 by 50, that is nothing but 30 by 50, that is equal to 3 by 5. These are the basic probabilities. Any questions, guys?
So, what in real time are we going to use only these four?
Just from in this session we are going to, can you please mic in mute? Yeah, in this session we are going to carry out the 2 points. From these sessions we are going to calculate the we are going to carry out going forward, we are going to take the 2 points. First one will be the probability ranges, the probability value 0 to 1. From this session take away points. Take away points. First one will be the range of probability range, that is nothing but 0 to 1. Next, probability of yes, probability of A means, as an example, A probability of occurring event A. In event A plus it can be A, B, C, D, anything it can be. Next, third point is rare events. Third point will be rare event. Rare event is nothing but the probability of those events are very, very small or minute. We are not going to consider the rare event to in our analysis. You may get that doubt. Where we are not considering to our analysis. So that is the reason this point we are going to consider as a takeaway for the next sessions. And again, in these are the takeaways. And apart from this, we have the probability has been 2 types. One is the addition rule. Probability types: addition rule, multiplication, addition rule as well as a multiplication rule. For today's session, let's have a discussion about the addition rule. Tomorrow we are going to discuss about the multiplication rule, because as the time doesn't permit to us. Let's have a discussion about the addition rule. Before we are going with the, do you guys have any questions? Before we are going to discuss further, do you guys have any questions about the probability basics? before we are going further, do you guys have any questions so that we can have a discussion now?
The relative frequency,
No, Koti.
Yeah, thank you. Huh?
relative frequency of heading. Coin dice coin వేసినప్పుడు టూ వస్తాయని చెప్పారు, ఈక్వల్ వస్తాయని చెప్పారు. డైస్ వచ్చిన డైస్ రోల్ చేసినప్పుడు కూడా ఈక్వల్ వస్తుంది.
How come it will be equal? We are not. There is a probability of getting equal. Either one can happen, two can happen. But we are perceiving only one portion. We are not perceiving all the other portions. Only particular event only we are looking, right? Either head or tail. But we are not looking simultaneously both. It is not possible to get the both the events at a time. Either only one event will happen. Suppose if you coin a toss, either head can happen or tail may can happen. But is it possible to get the? Is it possible to happen both the things at a time? No. That is.
డ్రాబ్యాక్ చెప్పారు, ఈక్వల్ ప్రపోర్షన్
Equal proportion doesn't happen. Equal proportion means here when we are trying to classify the things, like when we use the classification, either we are classifying wrong classification or right classification. Those kind of things doesn't happen with the relative frequency. Each and every events are getting independent with the other events. It doesn't happen equally. Like equally means equal proportion to get the wrong classification or right classification. That is the. Now let's have a discussion about the addition rule. Addition rule means combine two or more events. To combine the two or more events are called as compound events. To combine the two or more events. But ideally we generally consider the two events in the addition rule. We cannot consider more than two events. Let's say probability of A is the one event, probability of B is the another event. We are combining the two events. Those are probability of A union B is equal to probability of A plus probability of B, probability of A intersection B. Probability of A intersection B. Let me have a discussion about the this thing. Okay, let me have a discussion about this thing, like why we are keeping minus A intersection B. Why we are keeping minus A intersection B. To combine two or more events are called as the compound events. Let's assume that probability of A is the one event, probability of B is another event. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Though that is the main formula for the addition rule. Why we need to minus the A intersection B? Why we need to do the minus the A intersection B? Let's say Venn diagram. This is the A, this is the B. So A and B are the two events. For example, let's say some common portion in the A as well as some common portion in the B which are same. Some common. So when I adding the A plus B, does it counted twice or once? Twice, right? Common portion, right? Let's say I have a is the 1, 2, 3, 4, 5. A is equal to B is equal to 2, 3, 6, 7, 8. When I add in the A union B, 1, 2, 3, 4, 5, 2, 3, 6, 7, 8. Of course, we will do the A intersection B. Just Ideally, how does it happen? So here in the A data set, 2 and 3 are the common. In the B data set also 2 and 3 are common. But here 2 and 3, how many times it is counted? 2 times. But as per the rule, as per the addition rule, none of the record should not be counted more than once. As per the general theory of addition rule, none of the record should not counted more than once. As per the general theory of addition rule, none of the records should not counted more than once. So what do you mean by none of the record? Let's say 2, 3 in the A data set as well as 2, 3 in the B data set. Suppose I am adding the 2 thing, how many times 2 and 3 are counting? Twice. So that is the reason, whatever the common portion in the both data set, we are removing it. That is the reason in the formula P of A union B is equal to P of A plus P of B. When we set the P of A plus P of B, that means 2, 3 in this example, 2, 3 which is counting twice. But as per the rule, it need to be count only once. So that is the reason what we are doing, P of A plus P of B minus P of A intersection B. What comes under the P of A intersection B? 2, 3. So automatically we are removing the one set of 2, 3. That is the reason we are using minus A intersection B. Okay. Now let me draw a one as an example. A and B are the events A, B. Here in this case, let's say independent. Independent means there is no common portion. Independent means A and B data set, there is no common portion. Then P of A union B is equal to P of A plus P of B. If yes, then P of A union B is equal to P of A plus P of B minus A intersection B. Sorry. Yes. No, sorry, my mistake. It is independent means there is no common portion. If it is just P of A union B is equal to P of A plus P of B. If it is no means P of A union B is equal to P of A plus P of B. P of A plus P of B. P of A union B is equal to, yes, now it is not. Okay, now this is the meaning of P of A union B is equal to P of A plus P of B minus P of A intersection B. Let's do a practice for this as a lab session. Okay, let me pull the here here as per the addition rule, disjoint means there is no common portion. Then the formula is P of A or B is equal to P of A plus P of B. If there is a common portion, then P of A or B is equal to, A or B means nothing but A union B. P of A plus P of B minus P of A intersection B. Disjoint means independent, or we can say mutually exclusive events. Okay, here let's say if you go this formula, what is this formula? A is equal to green ball, B is equal to blue ball. Both are disjoint events. Both are disjoint event means there is no common portion in the data set. Disjoint event is nothing but there is no common portion between the data set. Then what is the formula? P of A union B is equal to P of A plus P of B. What is the probability to get the green ball? Four by 8. 8, right? What is the probability to get the green ball? 4 by 8. What is the probability to get the blue ball? 1 by 8. Then total will be 5 by 8. The probability to get the P of A or the P of A and B is equal to P of A plus P of B. The reason is that there is no common portion between the two data sets. Then the probability of green ball is getting 4 by 8. The probability of blue ball is getting 1 by 8. That is nothing but 5 by 8. Okay. Next, here in this case, A is the even number. Can anyone guess what are the even numbers? 0, 2, 4, 6, 8. What is the number which is greater than 5 means? 6, 7, 8. So in this case, does it the disjoint events or not the disjoint events? No, these are not the disjoint events. The reason is that 6 and 8 which are common, so not disjoint events, some counted twice. Then what is the formula for this? P of A union B is equal to P of A plus P of B minus P of A intersection B. So in this case, P of A or B is equal to P of A. P of A means the number which is the even number. How many are the even numbers are there? 0 is the one even number, 2 is the one even number, 4 is the another even number, 6 is the another even number, and 8 is an another even number. So in this case, how many even numbers are there? There are total 5 even number. The probability of A even number is 5 divided by total number is 10, right? If you calculate all the number, total count is 10. 5 by 10. What is the B means? The number which is greater than 5. That means 6, 7, 8, 9, right? In the both the cases, 6 and 8 which is counted twice. As per the general theory of addition rule, none of the records should not counted more than once. So we need to remove the 6 and 8. How many records are there? 2 records. 2 divided by 10. So then answer is 7 divided by 10. 5 plus 5 divided by 10 plus 4 by 10, that is 9 by 10 minus 2 by 10. That is nothing but 7 by 10. That is nothing but 7 by 10. Is it clear? Now let's take one more example. Any questions, guys, who are in the call?
No, Kote.
Yeah, thank you. Contingency table. Let's say the matrix format kind of things are called as the table which looks like this is the contingency table. In the contingency table, we have the 4 different classes: men, women, boys, girls. For 4 categories, we have 2 sublevels. One is survived and other one is dead. Now these are the numbers. Now we would like to find the probability randomly selecting a man or a boy. Randomly selecting a man or boys. Does men or boys, is there any common portion between the men or boys? In the men we have a survived, in the men also we have a dead. In the boys we have a survived, in the boys we have a dead. Is there a common portion between the men and the boys? Is there any common portion? There is.
Both are male.
Of course, both are the male, but we are not discussing about the men or male. So both are the male, I agree. But in this case, men is the boys, it means who are the less than 18, they are called as the boys. Who are the more than 18, they are called as the men. So there is a clear distinction between the men and boys. So there is no dependency in between the men and boys. So we can say that men and boys are the disjoint events. Men and boys are the disjoint event. Then what is the probability? P of A plus P of B. What is the P of A? 1692 divided by 22223 plus 64 divided by 22223. So the answer is 79%. The probability randomly selecting a man or boy is 79%. Now both are the disjoint. For example, what do you mean by contingency table? Here in this case, we want to find out the same case. Find the probability random selecting a man or someone who survived. Let me please understand the question. Find the probability of randomly selecting a man or someone who survived. In this case, randomly selecting a man or someone who survived means first man is that under the man we will get both survived as well as dead. Second case, we need to select only survived. In the survived, men will come, women will come, boys will come, girls will come. So men survived is repeating twice. If you go with this, does the men survived is repeating twice? Men survived is repeating twice. Is it clear? Men survived is repeating twice. In this case, what is happening? So what is the formula? P of A plus P of B minus P of A intersection B. In this case, what is the P of A? Men 1692 divided by 22223 plus someone who survived. How many card? 706 divided by 22223 minus 322. Only survive, right? 322 divided by 22223. That is equal to 2066 divided by 22223. This is the meaning. And those are the not disjoint events. Those are also called as the overlapping events. Those are also called as the overlapping events. Here in this case, setting up a contingency table. Can anyone in that we have to set up the contingency table. Contingency table means the table which is looks like this. The table which is above the one. Contingency table looks like. You have to create a contingency table. In a test of the allergy, drug cell done. Allergy drug is the allergy drug. First one is a cell done. 449 of 781 users experience the headache. 49 of 665 users placed by users experience the headache. 24 of 626 people in the control group experience the headache. Then how do we set up the contingency table? So in the Sheldon placebo control group, we have the two things, headache versus non-headache. Sheldon users, 49 Sheldon users are experiencing the headache. 49 no headache is 732. Total is 781. Placebo users experience headache 49. No headache is 616. The total is 665. Control group 24. No headache is 602. Then total is 626. The total counts are 2072. Here the complementary events, P of A and P of A bar is the disjoint or non-disjoint events? Disjoint, because there is no common portion of the two events. So all simple events, either A or A bar, are always disjoint events. P of A plus P of A bar is equal to 1. P of A bar is equal to 1 minus P of A. P of A is equal to 1 minus P of A bar. Let me same thing in the, assume that within the Venn diagram is P of A, out of Venn diagram will be P of A bar. Within the Venn diagram, this is the Venn diagram, within the Venn diagram will be P of A, out of this will be circle will be the A bar. That is the meaning of addition rule. Any questions, guys? Anyone is not cleared with the